What color should I use? Orange. There you go. Thank you, Shaylin. Appreciate that. All right. Right. I have no idea. Maybe it'll be in the comments section of the previous video. That could be. Yeah, we'll just do it by popular vote. All right. So help me out. What do we already know about the eye? What did we already talk about the eye? We talked about the anatomy of the eye. So what do we obviously then have to talk about next? Physiology. Physiology of vision. Perfect. All right, so what does the eye respond to? Light. So let's go ahead and draw a light bulb. It doesn't quite connect. Something like that. Little dot down there. All right, a little bit of physics. Right? I love this. So light bulb needs electricity, right? And so the way that a light bulb works, at least an incandescent light bulb, right? You got one end of the wire attached to the little dot down at the bottom of the light bulb, and then it goes up, and then it coils around, and then you got the other end of the wire attached to the metal screw-in thingy part of the light socket, and that's the circuit, right? What do you always have between the dot and then the metal screw-in part? You guys don't know light bulbs? Plastic. What is plastic? It's non-conductor. It's an insulator, right? And so you have to have one wire connected here, and then light gets emitted, and then the other wire connected there, and then you have to insulate. You have to have plastic there. So we need light, obviously, to see stuff, right? How does light help us see stuff? Okay. So the light, right, shines, right, and then some of that hits an object, and then what does it do? It reflects, right? And that's how we see, is light bouncing off objects. And you guys remember from regular biology, right? Green plants appear green because they reflect green and they absorb all the other colors of the electromagnetic spectrum. All right, sweet. So a couple things then with physiology of vision. What controls how much light goes into the eye? No. The iris controls the size of the pupil, right? So the iris is the colored part, right? And the pupil is the center part where light passes through. So the iris expands if you're in a what room? Dark room, and it contracts if you're out in bright light or bright sunlight. So iris controls the amount of light that's let in. Who picked orange? Horrible color. Horrible color. I could, yeah, that's my fault. Yeah, okay, fine. There we go. Okay, now everybody's happy. I like it. All right, sweet. What's the next structure that light goes through? The lens, and what does the lens do? Yeah, sort of. Maybe the lens flips it over. Yeah, so it focuses it, right? So the lens focuses for far or near. Does everyone's lens work properly? No. No. So I have to take a little time out and talk about nearsightedness and farsightedness. So if you are nearsighted, you can see things close to you, nearsighted, right? Like that makes sense. Things off in the distance are blurry, okay? So nearsighted, the focal point that your lens focuses the light down into is in front of the retina, right? So nearsighted focal point, FP, focal point, is in front of the retina. Farsighted, you can see things far away, but you can't see things close up, right? That's why when you see Mr. Ricks up there on the stage, like trying to hold the book like really far away, right? He's farsighted, so he can't, right? He's trying to hold it like longer than his arms can reach, because the image, the focal point, is actually behind the retina. So FP is behind retina, R-E-T-I-N-A? Yeah. And then Mr. Waters, who teaches physics this year, would totally geek out on the different types of lenses, right? So here is a concave lens, and here is a convex lens, and they do different things to the light so that the focal point is restored to where it should be on the retina. Pretty cool. And then last thing, excuse me, last thing is that you'll notice the image that's projected on the retina is upside down. Yep. So image. Image is upside down. So why don't we see upside down? The brain flips it. Is there anything that we could do to make our brain flip it back?
You're upside down.
Your eyes are seeing it upside down right now.
So like
your brain is flipping it. Your brain is making it make sense. Yeah, yeah. So here's a fun little 4-minute video about that exact phenomenon.
We rely on our eyes to guide ourselves around the world. It's all about coordinating our sense of vision with our bodies. But we're not even born with the basics.
All right, next page. Could I have a live stolen tomorrow? All right, so help me out. What do rod cells see? Or help us to see? Yep, general shape. So rod, general shape. And then cone cells help us to see color. Right? And again, light is a wave. It's just a small little part of the electromagnetic spectrum. Right? Ultraviolet is what bees and insects sometimes see in, so flowers look different to them than they look to us. Infrared is basically heat, and that's what night vision goggles kind of operate on, is the red side of the spectrum, or heat. So here we'll just write down bees, and then NVGs, night vision goggles. So our rods and our cones, they are stimulated by different wavelengths, right? So here are short wavelengths, right? And then here are long wavelengths. And so Hank already told us we have three types of cones. So we have a cone that is sensitive to red light. We have a cone that is sensitive to green light. And we have a cone that is sensitive to blue light. Now those cones, those cells, right, obviously they have to have what in their membrane to make them work? What are the workers in a cell, in a body? Proteins. Proteins. Can we make proteins wrong? Yes. And what does that lead to? Color blindness. Right. So, here's what someone with normal color vision, right, would see. And then we can have different types of color blindness depending on which cells, which type of cone cell is affected. Or if all the cone cells are affected, there is a type of color blindness where literally you just see in black and white. You don't see any color at all. So that's one problem that can happen with vision. And I couldn't leave because the next slide is, oh come on, there it is. The next slide we're going on to the ear. So I just couldn't leave vision without doing some optical illusions with you guys. Yeah, I know. So I wasted a lot of trees, but that's okay because it's worth it. So let me hand this out real quick. All right, so this first one with the plus and with the dot, right? This is really cool. Okay, so where your optic nerve comes into your eye, right? There's no cells where your optic nerve comes into your eye. There's no cells right there, and so you have a blind spot if you're just using one eye. Now, normally we use two eyes, and so our brain kind of fills in that blind spot. But to find the blind spot, you cover your right eye, and then with your left eye, you look at the plus, and like right there, for me, right about there, I cannot see the black circle. Stare intently at the plus, and then the black circle goes away. And move it back and forth or up and down to try to, so it moves in and out of your blind spot. I know. Yeah. All right, and then go ahead and turn the page. So look at number 4. Go ahead and turn the page to the, counterclockwise direction. Right? Do you guys see an X? Yep. Is it concave or convex? Concave, it scoops, right? So go ahead and return the page to normal, and then turn the page clockwise. You guys see that X?
Yes.
But now it's like a dome. Right? In the middle. It goes from corner to corner. The X goes from corner to corner.
And now it looks like they're moving out.
And the words explain it because humans assume that light comes from above because that's most of our experience. And so if you mess with shading, you can mess with the shape of something, right? So the next little bit, we can look up at the smartboard to see these. These are also on your paper, just because I want to convince you that it's not anything electronic that it's doing, but if there's movement, like you can actually make it move on the paper as well, right? So this is just kind of a fun little picture, right?
Oh, it moves.
Right, the black dots move. If you're staring at it, it's not black, but then if you're not staring at it, then it is black. Yeah.
They're like red and they're like still jumping.
And then of course these lines are parallel, even though they don't look parallel. Because your brain is trying to make sense. And in trying to make sense, then it tricks it. It got bigger. Oh yeah, you can do this one on the paper.
It moves.
So do this one on the paper and do like this.
Wait,
Focus on the black dot.
is it gonna move?
Yeah.
Wow, it actually moves.
And then they actually turn. I know. Oh, here, this is a good one too. You can do this one on the paper. So if you're looking at it, it stays still. But then if it's on your peripheral vision, it looks like it's spinning. Yep. Always straight. Yeah. They're the same size.
What? No way.
Yeah. Get a ruler, figure it out. This one we've already done. Same thing. What do you guys see? Huh?
Wire? How do you see wire?
Liar. L-I-A-R. Liar. Yeah. All right, this is my favorite. This is my absolute favorite one. Which square is lighter? They're the same color. Even though beach, watch this.
What?
They're the same color. A and B.
Oh,
A and B. A square, B square. Yeah.
Oh, I thought you meant like all of them were the same.
No. But like you can see the line here. It's right, but then here, it's the same color. Here, it's the same color.
Lie.
Right? But then there, it's yeah. So your brain knows that this is in shadow, and so something that's shadow is usually darker. So it adjusts your perception of this color to make it appear lighter because it knows it's in shadow and it's darker. So your brain's messing with you. Yeah. Can't trust anyone. And then the magic eye where you cross your eyes and you see a shape and whatnot. Alright, how do we get out of this? There we go. Sweet. Alright, you guys ready for a break? Yeah. Go take a break, get some water, use the restroom. right, so like I said, once we get through this diagram, we're done. The ear and hearing and how that works is actually going to be the last thing that we're going to talk about in chapter, I think it's 8 is what we're in. So we're probably looking at a test end of next week-ish over the nervous system. Chapters 7 and 8. So just FYI. And if we're doing distance education, I have no idea how tests and quizzes are going to work. So we'll figure that out when we get there. I might just make the tests a little bit harder, but then they're open book, so that like there's no way that you can cheat because I'm letting you use the book. So I don't know. We'll see. We'll see. That's one idea that kind of crossed my mind. Yeah. No. I won't. No. All right. Here we go. I'm gonna know that everyone has a Facebook group when like everyone gets like number 1 wrong with the same answer. Yeah, or Instagram or whatever you guys use. Yeah, everyone has the exact same answers, including the wrong answers.
I tried to go on Facebook for like the first time in a year the other night.
Yeah.
And it literally won't load with so many notifications.
Oh yeah. I had Facebook when I was doing my graduate program at WSU because that's the way the instructor communicated with us, but I haven't logged on in like 5 years because I only had it for school. All right, I digress. The outer part of your ear is called the auricle. And then moving in, so this is where all that ear wax develops and where you get your Q-tips, stuck in there and everything like that. That is called the external acoustic meatus. External acoustic meatus. And then, of course, this little white sheet right here is called your, right, that's what normal people call it. However, we're going to call it tympanic membrane. Oops, T-Y-M. Sorry. I wish we could call it eardrum. That would be so much easier to spell. And then we have the bones of our ear. Do you guys remember what they are? Yep. So I believe this is the malleus. The hammer, the anvil, and then the stirrup. So malleus. Hammer. Incus. Anvil. And then stirrup. Stapes. We'll skip 6 and 7. We'll come back. I'll explain why here in a second. Number 8 is your vestibulocochlear nerve. Vestibulocochlear nerve. 9 is called the round window. 10 we don't care about. And 11 is your pharyngeotympanic tube. Pharyngeo, what do you think that refers to? Pharynx. Yep. So that's why if you're like going for a plane ride, which no one wants to do now, and you have to pop your ears, you swallow, and it changes the pressure in your ears because your throat and your ears and your eyes and your nose and all that stuff is all kind of interconnected. So plug your nose, right, and do the Valsalva maneuver, and then that changes the pressure, right, in your ears. You can pop your ears that way as well, because it's all connected. All right, back to 6 and 7. So 6 and 7, like they're structures, but they're not really structures the way that they're pictured. So it's kind of like there's your skull bone, right here, and 6 and 7 are kind of like cavities within the skull bone. So it's not an actual structure, but it's a lack of osseous tissue. It's a lack of bone. It's like a cave, or whatever you want to call it. It's like little paths through the bone. So number 6 are called your semicircular canals. And then number 7 I want to say Coachella, but it sounds wrong to me. It's Coachella. Cochlear, yeah. So anyways, we will have a quiz. Let's see. We're going to the Cadaver Lab Friday. So how does Monday sound for a eye without a word bank and ear with a word bank? All right, let's do it. Monday.